take it up a notch. What should we worry about more than tornadoes? Tropical cyclones. Never heard the term? No problem. Tropical cyclones, they go by different names in different places. All right. So, in North America, they are called hurricanes. In the Indian Ocean, they're called cyclones. In Southeast Asia, they're called typhoons. Different names for the same thing. They're tropical cyclones, it's the technical name. We call them in North America hurricanes. They are the most violent storms on Earth. Taking it up a notch. An average-sized hurricane has the energy equivalent of 10,000 nuclear bombs. Thinking back a few videos to when we were talking about energy, how much energy is in the atmosphere when that energy gets condensed under the right conditions to create a tropical cyclone, hurricane, there's a lot of energy there. That's why it's the most violent storm on Earth. Excuse me. So you get a lot of wind, carries a lot of energy, a lot of moisture, a lot of rain, a lot of weather patterns, a lot of flooding, all of that energy. Hurricane season for us in North America in the Atlantic Ocean is typically between June and November, but the peak is kind of August through October. So August, September, October, that's peak hurricane season for us in North America. Now, I say this because beware. Beware of cheap flights to places like Florida or the Caribbean islands during these months. There's some great deals you can get to Florida, to Miami, to to Puerto Rico, to whatever, to the U.S. Virgin Islands, to all these Caribbean islands. The reason it's so cheap is because you're going during hurricane season. So just keep that in mind. So how do tropical cyclones, I'll just use the term hurricane since that's what we're used to. So how do they form? Well, there's 4 stages. You know what, before we do, let me give you another part of the super secret code. It is the number 6. You got me? The number 6. One more time. The number 6. Stage 1, we get something called a tropical disturbance. So there is some sort of organized thunderstorm activity that stretches out at least 100 miles across and maintains its identity for more than 24 hours. It's called a tropical disturbance. The storm just doesn't become a hurricane. You get some organized thunderstorm activity across a wide section, and that's considered a tropical disturbance. During the summer, these disturbances often start as storms moving westward off the coast of Africa in what are known as tropical waves. So for our hurricanes, they actually start in Africa. That initial storm usually begins and blows off of Africa. So remember, down in this section, as we get towards the equator, the weather patterns are moving kind of from east to west. So we get this weather pattern kind of blowing off of Africa, and that's where it starts at these waves of storms kind of coming off of Africa. Stage 2, that disturbance turns into what's called a depression. Under the right conditions, a disturbance can develop further and start to spin around a low pressure center. Once that happens, it's considered a tropical depression. So you get this wave of storms, 100 miles or so wide, moving off the coast of Africa, and if for some reason they now begin to start to rotate and spin, now we're talking tropical depression. Now, the right conditions for that include the water has to be warm enough to fuel the system. Warmer water contains more heat. Heat's a form of energy. So the water has to be 80 degrees Fahrenheit or hotter. That's why in the northern hemisphere, in the North Atlantic, it's late summer months that we get hurricanes because it takes time for that water to heat up. Water heats and cools slowly. So you need warm water. That's why it happens in our summertime, or towards the end of our summertime. You need enough moisture in the lower and middle parts of the atmosphere, so that stuff coming off of Africa, those storms coming out of Africa. Local winds also have to be arranged so they allow depression to spin. So you need enough wind to get it going. Not enough wind, it will not spin the depression. Too much wind can tear apart the spinning depression. So you need that difference of wind directions at different elevations. All of that helps to kind of create that spin. And once you do, you've created a tropical depression. Here's a little diagram on how that works. That's stage 2. Stage 3, the depression becomes a tropical storm. Maybe you've heard of this term. So when the pressure in the center of the depression drops, so low enough pressure, air begins to rush in. As that air begins to rush in, you're creating strong winds. So if the system strengthens and the wind speed rises past 39 miles per hour, that depression is dubbed a tropical storm and is given a name. Tropical storm whatever. Tropical storm Kovac. We really rely on data from islands and buoys out in the ocean, as well as aircraft that fly through these storms and near these storms. Literally, they fly through the storms to measure wind speeds to kind of gauge what's going on. How fast is the air moving? Has it reached 39 miles per hour or higher? So literally, you get different types of planes flying into these storms. If you can imagine that, imagine the bravery it takes just to fly a plane through a tropical storm or a hurricane. So that's stage 3. Stage 4 is when that tropical storm becomes a hurricane. So storms can intensify very quickly if they pass over a region of especially warm water. Warmer water, more precipitation, more moisture, more heat, more energy. That's all it's fuel for this hurricane. So the winds pick up and the system gets rounder and often forms a more clearly defined eye as it turns into a hurricane. So there's this kind of center, what's called the eye of the hurricane, that begins to develop. When the winds in this tropical storm reach a sustained, so constant 74 miles per hour or more, then we classify it as a hurricane. Hurricanes are classified according to the Saffir-Simpson scale based on their wind speed and propensity for damage. So when we're talking about Category 1 hurricanes, winds from 74 to 95 miles an hour, Category 2, 3, 4, etc. Category 5, 155 miles or more. That is also tied to storm surge on average. If you remember back to that unit on flooding, storm surge is a type of flood. That's typically what does the most death, what's create the most death in a hurricane. Damage, the winds, we're talking about winds at that excess of 100 plus miles an hour. That's what's going to cause houses to be torn apart, trees to fall, etc. But what does a lot of the killing is that storm surge, and that's tied to wind. The faster the wind is blowing onshore, the more water is going to get pushed up onto onshore. So Category 1, 74 to 95 miles per hour, can cause about a 4 to 5 foot flood of storm surge into an area. Where Category 5 could create a storm surge, a flood of 20 feet high, that water getting pushed up onto land. So here's the map of all tropical cyclones, hurricanes, typhoons, whatever you want to call them. So again, you can see the path of hurricanes that really start off in Africa and they head west, and then as they kind of move north, then they catch the winds that go from west to east, so then they're kind of blown back east. But that's why they don't kind of just continue, like over Mexico or into Arizona, because they get these other winds that push them the other direction. But you can see there's the hurricanes affect most continents except for South America. South America seems to escape. Looks like there was one in this time frame. Again, hurricanes, cyclones, typhoons, they affect the majority of Earth. And pretty much all form the same-ish way, different stages, just different names depending on where you're at. So this is a satellite image of a hurricane. Here's the clearly defined eye of a hurricane. It's all kind of rotating around. You see these spiral arms, and these can be hundreds of miles wide. Storm surge. The fastest winds are going to be closest to the eye of the storm. So on the news, if they're talking about the eye of the storm is moving over Louisiana, well, the fastest winds are right around here. So, oops, let me go back. So if this eye is passing over your area, that's the fastest winds are going to be there. Out here, it's still a hurricane. So out on the arms of the hurricane, slower winds, but you still get precipitation and such. But then again, you get the storm surge. Again, 'cause if it's rotating this way, right, the wind is pushing water up onto the shore. So it's kind of pushing it up on one side. On the other side, it's not. On one side, it is. So storm surge, depending on the track of the hurricane, storm surge on one side of the hurricane, not so much on the other side of the hurricane, because the wind's blowing in the opposite direction. If you slice a hurricane in half, this is kind of what you would see. Again, these spiral arms, eye of the hurricane. Again, the fastest winds are going to be closest to the eye of the storm itself. So these storms can bring a lot of rain, obviously floods, high winds. They can move fast, they can move slow, but they need that warm water as an energy and fuel source for precipitation and heat as a form of energy. Once hurricanes move off the ocean, so once they move onto land, they typically die out in a day or two because they don't have that energy source. They don't have that warm ocean water to fuel them. That's what they need. So as soon as they move on land, you're going to still get a lot of thunderstorms and intense storms, but it rapidly dissipates. So it's kind of dangerous when a hurricane does kind of make its way on land, goes back off to the ocean, regains some energy, comes back onto land, and it's full force again. So they can bring a lot of rain, but there's a number of things that can go wrong with hurricanes. This is what it looks like in the eye of a hurricane. If you were to stand there and kind of look up once the eye passes you, so it actually is relatively calm once you're in it, but around it, this what's called the eye wall, once you get into the actual hurricane cloud system, that's where the fastest moving winds are. So, once the eye moves over you, if you're in the eye, it's relatively calm, but once the other side of the eye continues, bad stuff. So, where in the U.S. gets the most hurricanes? I mean, if you just pay attention to the news, you typically can figure out it's usually the southeast, anywhere from Texas, even all the way up the East Coast, even into Maine. But you can see by far Florida over the past 150 years or so has the most direct hurricane hits as far as on U.S. mainland. Florida takes the brunt of it there. Louisiana, Texas, North Carolina also gets some of that as well. A lot of it in the southeast, but hurricanes can, again, as they start to move north, get pushed to the east, so they can make their way kind of up, and they can hit this area if they get refueled, because again, there's a warm ocean current all off the east coast, which gives excellent fuel for that hurricane. So hitting New York, Massachusetts, it's not unheard of hurricanes. Not huge Category 5 hurricanes. The bigger hurricanes are usually going to hit down south. There's going to be a little bit smaller category hurricanes, but these areas aren't prepared for hurricanes, so the effects can be that much worse. Top 10 most costly hurricanes. Hurricane Katrina, the biggest one that hit New Orleans, flooded 80 to 90% of the entire city. People moved forever away from New Orleans, never allowed back. So much death and destruction, $170 billion worth of damage. And you can see most of these are in the 2000s, with the exception of Hurricane Andrew in the 90s, almost 30 years ago, but that was a big one. Average number of hurricanes per decade per city. The 3 cities in North Carolina, this is specific cities, not states, but some areas in North Carolina as far as cities are the most hit. And then as far as top 10 cities that are most vulnerable to storm surge, and this is the number of single family homes are at risk, no guess, Miami, Florida is number 1. Please don't move to Miami. Oh, it's cool and nightlife and blah, 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 blah. Yeah, hurricanes. And they're running out of water. It's actually subsiding, sinking to the ocean. Miami's garbage. As far as hurricanes ranked by fatality, a lot of these are almost over 100 years old. In modern day, again, Katrina, when that occurred, there was 1,200 deaths. All that economic destruction as well. You can see a lot of these are much older, so you can see. And why do you think that's the case? Right, less infrastructure, less warning, so that's why you get a lot of deaths. But again, that's why Katrina really sticks out here. Why it was so bad? It's just this. It was a nasty one. And looking at the percentage of deaths in tropical cyclones, in hurricanes, during this time frame, 76% tied to storm surge, flooding created by rains, or river floods due to rain and precipitation. So 76% of deaths are associated with some sort of flooding. That's where the death is such a big issue, is the flood, it's the water. Okay, that's tropical cyclones. We'll pause here. We'll change gears a little bit when we're talking about a different type of weather hazard. See you back here in just a second.